Have you ever really stopped to think about how you'd get a hot meal if you were totally off the grid? Well, today we're going to dive into the really clever engineering that makes that possible, and, even better, how you can start thinking like an engineer to solve all kinds of problems.
Okay, so picture this. A big storm rolls through and boom, the power's out. No stove, no microwave, nothing. How in the world do you heat up a meal? It sounds like a simple problem, but solving it leads to some pretty fascinating engineering.
I mean, this is a real problem that pops up in all sorts of emergency situations. You just have to think back to huge events like Superstorm Sandy, where whole communities lost power for days or even weeks. In those moments, the simple act of cooking just vanishes.
And here's what's so interesting. A warm meal is so much more than just calories. There's a proven link between physical warmth and our feelings of emotional comfort. So when everything's gone sideways, that little bit of warmth isn't just nice to have, it's a piece of feeling normal again. It's a huge deal.
For a long time, the go-to solution for aid workers and the military has been the MRE. You've probably heard of it, the meal ready to eat. It's this all-in-one package that has the food, sure, but it also has its own tiny portable heater.
And the real star of the MRE is this thing called a flameless heater. Seriously, the first time you see it, it feels like a magic trick. You don't plug it in, you don't light it, you just add a little water, and suddenly you've got a hot meal.
And using it couldn't be simpler. You just take the food pouch, you slide it into the special heater bag, you pour in a little water up to the fill line, fold the top over, and you just wait. A few minutes later, your food is piping hot.
Which, of course, brings us right back to the big question. If there's no flame, no outlet, and no batteries, where's all that heat actually coming from? The secret? It's all chemistry. Inside that little heater pouch is a mix of powdered magnesium and iron, and when you add water, it kicks off a super fast chemical reaction. It's basically a controlled rusting process that happens in seconds. It's what we call an exothermic reaction. Exo meaning out, so it's just pumping heat out. Think of it like a supercharged hand warmer. That reaction also lets off a little hydrogen gas, which is totally harmless, and it's why you see the bag puff up.
So, okay, problem solved, right? We've got this amazing, portable way to heat food without fire. Well, not quite. In the real world, MREs are a fantastic idea, but they come with some pretty serious downsides. And we're not talking about small things. These heaters are expensive. They can be hard to get a hold of, especially during a disaster. The instructions can kind of be confusing when you're stressed out, and just physically getting them to the people who need them is a huge challenge.
And when we say high cost, we are not kidding. We're talking about $15 for one single meal. For an aid organization trying to feed hundreds or thousands of people, that cost becomes impossible fast.
So, this is the moment where we need to shift how we're thinking about this. We see the problem, we see the flaws in the current solution, so the question becomes, could we engineer something better? Could we design a homemade version that's cheaper and easier for anyone to use?
And that, right there, is the crucial switch. A consumer sees a flawed product, and, maybe they complain about it. An engineer sees those same flaws and thinks, okay, that's my starting point. That's the problem I'm going to solve.
And this is where every engineering project really begins. Before you build a single thing, you have to define the rules of the game. You need to figure out your criteria, what your design must do, and your constraints, the limits you have to work within.
So let's apply that to our challenge. Over on one side, you've got the criteria, our goals. It has to actually heat the food well, it needs to be safe so no one gets burned, and it has to be super easy to use. But then you have the other side, the constraints, our limits. It absolutely has to be low cost, it has to use common materials you could find almost anywhere, and of course, no flames or electricity.
See, this framework is what makes engineering different from just messing around in a garage. It's a deliberate process. It's a roadmap that guides you from a problem to a solution, and it's designed to work even when you hit dead ends. It's not about luck. And that process always starts with asking questions. This right here is a design questions board, a tool engineers use to just map out everything they don't know yet. The truth is, great solutions almost never start with an answer. They start with asking really good questions.
And just look at these questions, they're so practical. What materials could even work? Where would we find them? How hot does the food actually need to get? Is this thing safe? How do we make the instructions so simple anyone can follow them? Each one of these is its own little problem that has to be solved. So after you go through that whole journey,
From seeing the problem to asking all the right questions and testing ideas, what did you really create in the end? What's the real product?
This quote just nails it. The point isn't just to build a gadget. It's about taking on the role of an engineer. It's about using scientific principles to design a solution to a real-world problem.
And that, right there, is the true heart of engineering. The most important thing we built wasn't the physical heater. It was the process we used to get there. That repeatable plan of asking, testing, failing, and refining, that's the real invention.
And that process is a tool, a seriously powerful tool. Defining your goals, understanding your limits, asking tons of questions, and testing your ideas, you can apply that way of thinking to just about anything. The food heater was just an example. The real question is, what problem are you going to solve with it?